Good afternoon, everyone, and welcome to the 22nd World Congress of Soil Science. I'm from Murcia Institute of Agriculture and Environmental Research and Development, and I'm going to talk about the application of leaching potential indices in a clay-loam soil to assess the risk of groundwater pollution by triazole fungicide. First of all, triazole fungicides are systemic broad-spectrum which contain the 1,2,4 triazole ring belonging to the conazole group. They can affect soil quality and can move from soil to water bodies. Therefore, the objective of this work has been to examine the behavior, absorption, degradation, and leaching of three widely used triazole fungicides: flutriafol, myclobutanil, and triadimenol. We have used a clay-loam soil, which is a typical semi-arid Mediterranean soil, for assessing the risk of groundwater pollution by means of leaching potential indices. For this purpose, absorption, degradation, and leaching experiments were conducted at laboratory scale through the following experimental setup using the methods proposed by the Organization for Economic Cooperation and Development. Sorption studies were carried out following the batch equilibrium method, test number 106, to determine logarithm values of the organic carbon absorption coefficients. Secondly, degradation tests were performed in aerobic and dark conditions for 60 days following the test number 307 for aerobic and anaerobic transformation in soil to determine half-lives of fungicides. Finally, the leaching potential was assessed using disturbed soil columns in accordance with test number 312 for screening indices. Screening indices were used to assess the leaching potential of the fungicides in the soil: groundwater ubiquity score, relative leaching potential index, leachability index, and experimental leaching index. Table 1 shows the equation and the mobility criteria of each one. Soil and water samples were extracted with acetonitril, and the separation, identification, and quantification were carried out using an HPLC mass spectrometer. Table 2 shows the used analytical conditions, such as single reaction monitoring transitions, for quantitation and confirmation of each fungicide. Obtained results are summarized in Table 3. Firstly, low absorption in the soil was observed for the three fungicides. Secondly, the calculated half-life range from 79 to 136 days, showing moderate to high persistence in soil. Thirdly, as you can see in Figure 1, all fungicides were detected in leachates with percentage ranging from 12 to 26 of the initial mass added. Concentrations found in total leachates were in all cases higher than the maximum admissible concentration established by the European Commission for groundwater. In accordance with the screening indices used, all fungicides behave as mobile or very mobile compounds. In summary, our findings suggest that the studied fungicides are candidates to pollute groundwater resources, mainly in areas with intensive yearly rainfall regimes. In case you want more information, at the end of the poster you can find the reference of the published work in water, air, and soil pollution. Thank you for your attention. I hope that you enjoyed my poster. In addition, if you have further questions, please write me an email and I'll be pleased to answer your doubts.